Get up where we're at, number 12. We're doing ellipses. We got to finish ellipses for sure today. Ellipses. So, what do we got? A little 13, 15 of them left. All right, see what we can do. One every 3 minutes. All right, so there's our ellipse equation. Let me bring it over here. X minus 4 squared plus 4y plus 4 squared equals 144. 144. All right. So what do? We got to give that a new look. Do a little plastic surgery, remove the wrinkles, give it a look so we can graph it. So what we're always doing with these things is change the way it looks so it's easier for us to graph. So what do I mean change the way it looks? What kind of look do we need to give that so that we can graph that thing? Right? And specifically get a 1 on the right side. It's all about a 1, right? So for ellipses, and then same thing tomorrow for hyperbolas, it's all about a 1 on the right side. And it was not that way for parabolas, right? You guys just did the parabola homework last night. Did you? No. Oh, 2 nights ago. All right. So anyway, parabolas, it was all about getting a 4, and the x's and y's were on opposite sides, weren't they? But x and y are on the same side and get a 1 for these guys. Yeah, so get a 1, so that means I'm going to divide through by 144. Which will put a 1. Okay, now what does that do from there? 4 goes into 144. What's that, 36 times? So we get x minus 4 squared over 144 plus y plus 4 squared over 36. Good. Equals 1. So now we can graph it, right? This is 12 squared. This is 6 squared. So we can get a picture. Can you get a picture of that real quick? Yeah. And they're going to ask for the center and then the focus points and the vertices. So let me let you try that. So let me let you get a jump start and then I'll jump in. So we've got it in the right form. Now we can graph and get all that information. We're over here. This is number 12. $144. Right. Okay, so we got that. So for the graph then, what's the center of this graph? Yeah, remember the center is always opposite for all these graphs, right? So the center is going to be positive 4, negative 4, isn't it? Opposite. So positive 4, negative 4, right there. 4, negative 4, that's the center. And then where do we go from there? Well, whatever's underneath x is always right, left. So that means you go right 12, left 12, and find a couple of dots. Well, how do you find the coordinates of the dots? The easiest way is to take that center and, that 4, negative 4, and just add 12, and then subtract 12 from the x coordinates. So that'll be 16, negative 4. Is that good? See, that's the easiest way to find the coordinates, is just take the center and add and subtract either to x or y, for right, left, x, and for up, down, y. So I added 12, and now I will subtract 12, and it'll be minus 8 minus 4, right? That good for the two edges? Now, how about the up, down? Well, what's underneath y is 6, so that means I'll go up 6 and down 6, won't I? So up 6 and down 6. So how do you find the coordinates of those two new dots? Yeah, so you take the 4, negative 4, you take the center, it's up here, 4, negative 4, and you add 6 to the y, and then subtract 6 from the y coordinate, because up, down, huh? So that'll be, so this point will be 4, 2, won't it? We good there? And this one down here, oops, this one down here. Now we're going to subtract 6 from the y, so it's 4, negative 10. Is that good on all those? All right. Make the ellipse. Now, mine looks terrible. But it's really, this ellipse should be wider than it is tall, shouldn't it? It's wider. It goes right and left 12. It's really wider than it is tall. Sorry, it's a terrible drawing. But anyway, so last thing, I got to find the focus points. Focus points. How do you find the focus points? The foci. What do I do? Yeah, the Pythagorean with the minus, right? A squared minus b squared is c squared. This is where the C is where you find the focus points for the ellipse, right? Now, remember the A and the B. It's a little bit tricky. I don't know if let me try saying it this way, which may be more helpful. The A is the bigger, right? You got to put the bigger one first when you subtract two things, don't you? So the A is not always what's underneath X. It can be under X or Y. It's just the bigger. A is always the bigger. In this case, that is the one under X, right? 12 is bigger. So this is 12 squared minus 6 squared is c squared. 144 minus 36 is c squared. But what's that, 108? Is that what it is? 35, yeah. And then root it. Switch squared of 108, I don't know. 2 times 54, which is 6 times 9. It's a mess. I'm running out of room completely. So, yeah, I'm totally out of room. Here, let me try to squeeze it in a little bit better. Let me move this up. So root it. So 108 is 2 times 54.
Mr. Heron, someone said 12 times 7.
No, 12 times 9.
Oh, there you go.
Okay, right. 3, 3. So there we go. So break it all down. You've got 2 2's. Do you guys remember how to do all this? When you simplify a square root, just break it all down to its little pieces. Use a calculator. 2 times 54, 6 times 9, 2, 3, 3, 3. Break it all the way down. So we got 2, 2, 3. You know, you can, and 2 2's. It's a 2 for 1 deal is what I always tell my algebra students, right? It's 2 for 1. 2 whatever's in a root sends 1 to the outside, doesn't it? Right? So 2 2's in, 1 2 comes out. 2 3's in, 1 3 comes out. So that's 6. What's left inside? 3. This extra 3 right here is left inside. 6 root 3. You good with that?
No.
No?
I don't understand.
Okay, let me do it more slowly. So square root of 108. So what you do is you just break it down. So 54, any way you want. There's all kinds of different ways to break it down. But once you get it all the way down to its little pieces, put them all down here on the same line like that. Good so far. That's the guts of a 108. 2 2's and 3 3's. That good? And then when you got that, it's a 2 for 1 deal. Now that might seem strange or confusing to you, but if you think about it for a minute, that's what roots always do. Like you all know the root of 9 is 3.
Yeah.
Do you realize that 2 for 1 just happened there? What is a 9? 2 3's in, 1 3 out. You see, that's what roots always do. That's always what they do, right? They always do 2 for 1. We don't say it that way, but it's more helpful to say it that way when they're all spread out, right? So roots always do 2 for 1. So therefore, 2 2's in, 1 2 out. 2 3's in, 1 3 out. And they multiply when they come out, just like they were on the inside. So 2 times 3? 6. And what's left in? This extra 3 is left in. Does that make sense?
Keep that there.
If we do 12 times 9, that's the same.
Yeah, so if I did the 108 and you did 12 times 9, that's great. Keep going. What times what's 12? 3 times 4, 2 times 6. 9 is 3, 3. And then what's the 4? 2, 2. So you see what we get in the end? Bring these all down on the same level. See? 2 2's, 3 3's. 2 2's, 3 3's. It doesn't matter how you break it down. There's an official rule called the fundamental theorem of arithmetic, which says there's a unique DNA in primes for any number. In other words, there's only one way to break down. There's only one resultant breakdown into primes. It will not be different. It's like a DNA. It's the guts of the 108. 3 3's and 2 2's. However you do it, you'll get there. Yeah?
So the ones that are 2 for 1, we change them to just 1, we times them. Anything that's just left alone, like the 3, we just put it in square root.
Correct. Exactly. Is everybody good with that?
Yeah.
Right? Whatever there's 2 of, it ships 1 to the outside and then they're gone. And they're gone. But whatever's left over stays in. right? It's 2 for 1. 2 inside, 1 outside on that. So it becomes 6 root 3.
Is that the index again?
No. What's in the hook number is the index. Ours is understood 2. No, we're not messing with that here.
What if you threw in 3?
Is that good? Do you guys do that algebra?
No.
No?
No.
Yeah? No? Really? I mean, seriously? I can't imagine how your teacher would not, like,
He was bad.
I mean, it's just not algebra. You're not teaching roots. I mean, I'm teaching that right now in algebra.
He was straight bad.
Oh, straight bad. Okay.
Oh, no, I know.
Not crooked bad, but straight
Straight
bad.
bad.
It's a different kind of bad. All right, anyway, getting back to the 108. So what is it? 6 root 3? So that's the C, 6 root 3. So where were we? Oh, so where are the focus points? Are they sideways or are they up, down? Sideways. Yeah, because it's wider. Remember, so if the parabola is, ellipse is wider, then the focus points are sideways. If it's taller, they're up, down. Yeah, so it's going to be sideways, because even though my graph is terrible looking, it's straight bad. It's going to be right, left, isn't it? So right, left from what? From the center. From that 4, -4 center. So this is a big mess. Let me just put it over here. Well, that's a mess too. So let me go up here. So 4, -4. So from that 4, -4 center, 4, -4. I'm basically going to add 6 root 3 and subtract 6 root 3. Going to go right and left 6 root 3 to the focus point. So what are the focus points then? You just simply write that and you're done. 4 plus 6 root 3 minus 4. 4 minus 6 root 3 minus 4. We're done. I can't combine those. Remember, they're unlike terms from your algebra days? From your root experience in algebra?
Did you want the approximate?
I don't think so. I think they want just this.
They want just that.
They want just that. Yeah. Does that make sense on that? If the focus points were up, down, then I would have added them and subtracted them from the y coordinate, huh? So we good on all that? So it's all those messy details.
Add
Huh?
that to the X. Okay.
I did it to the x because it was right, left. Yeah. Exactly. To the x coordinate here. Yeah. Good. All right. Math teacher, you got to be a little bit of a sadist, I think. You know, you just enjoy torturing people with math. It gives me a twisted pleasure. Sorry. All right.
You need help with that, Mr.
Yeah, it sounds like I do. Yeah.
We got therapists.
Yes. We do indeed. All right. So there we go. Yeah, Taryn's totally right. We got to complete the square twice on this one. We got to do it on X and on Y. There's for sure one of these on the exam. We did it for parabola, but for parabola we only had to do it for one letter, because remember, parabola only has one letter squared, the other's first power. But ellipses and hyperbolas tomorrow, both letters are squared. So we've got to do it both. So what that means is, you got to do it for X, you got to do it for Y. Just yank this 9 to the other side. Just get him out of the way. So x squared minus 6x, leave a blank. Oh, and factor out, this is a harder one too. Yeah, let me definitely do this one with you. Plus 4y, leave a blank, move the 9 to the other side. Let me stop right there. Really important what I'm doing right there. Does everybody see that? So what I'm doing is I've got to complete it, which means I got to make it like this in the end, don't I? I got to make it like x plus some number squared, y plus some number squared. I got to make it look like that, don't I? That's the look I've got to give it so that we can graph. That's called completing the square, making it a square. I've got to make it a square. So that too was covered in your algebra days, maybe? No? All right, and so let me help with that. So to do that, you've got to add just the right number at the back to make those 3 x's factor, and then just the right number for the y to make those 3 y's factor as something squared. That's what it means. You've got to give it just the right number to make it factor as something squared. But as you do so, you've got to remember, whatever you're doing to the left side of the equal sign, you've got to make sure you do the same thing to the right side of the equal sign, so you don't really change anything, you just change the way it looks. Okay, so here we go. How do you find the number it needs?
Middle term.
Take the middle, halve it, and square it. It's always middle over 2 squared. You with me? It's always mid over 2 squared. That's how you find what I call magic number. Nobody else calls it that. But the magic number, just what's needed. So what do you get? Minus 3 squared, positive. It's always positive because it's squared at the end. So it's always positive. The magic number, the completing, maybe I should call it the completing number. The number that completes it, the completing number, is always positive. So add 9. That means these three will now factor. You can see it, huh? It's x minus 3, x minus 3. In other words, it's x minus 3 squared. See how that plus 9 made it factor perfectly? That's what that completing number does. And it's always found by mid over 2 squared. But if I added 9, that brand new 9 that I put on the left side, that was not there in the beginning of the problem. That's something I put in brand new on the left side, so I have to also put it in on the right side, so I haven't changed anything, right? Good so far?
Yeah.
Now, with the y's, notice I factored out first. So let me make note, that's really important. If you don't do that, nothing good will happen. First, factor out whatever's in the front of y squared or x squared. If there was any number in front of x squared, I would have done the same thing. I would have factored it out. So before you find the completing number, you've got to factor out whatever's in front, because that'll change the mid number, won't it? So it'll change the completing number, right? Which is the mid over 2 squared. So now find the completing. So I'm going to say, okay, it's 4 over 2 squared. It's 2 squared. It's positive 4, isn't it? So add 4. Good? That's the complete. Now these three are guaranteed to factor. Keep the 16 there. They're guaranteed to factor y plus 2, y plus 2. Sure enough, huh? Which is y plus 2 squared. Good? See how that made it factor as a square? I completed its square. I gave it what it needed to become a square. But, now here's the real trick part. Think carefully, think logically with me. Whatever you did to the left side, real effect, not just what it appeared to be, but what it really is. What you really did to the left side, you must really do to the right side. What am I talking about? I put a 4 here. Yeah, but not just a 4.
4 times 16.
A 4 times 16. Because that 4 is under the influence of a 16. If I was to multiply out, there wouldn't just be a new 4 there. There would be a brand spanking new 16 times 4.
But it would still
By putting a brand new 4 here under the influence of a 16, I really added whatever 16 times 4 is to the left side. So I have to really add whatever 16 times 4 is to the right side. Does everybody see that? Not just 4, but the real effect to the left side, which is 16 times 4, is brand new. So 16 times 4 must be on the right side, which is 64. So the right side is 64, because these 9s cancel. Everybody see that? That's pretty tricky. That's not easy to do. So I'm going to go to a fresh screen. You got that copied down? That good? X minus 3 squared there. What number is this problem? Number 13. Plus 16y plus 2. Y, what is it? Y plus 2 squared equals 64. Okay, we've almost got it in the look we need. What else do we have to do to give it the final look?
Divide.
Yeah, I got to get a 1 over there. Divide by the 64, huh? So 16 goes into 64 4 times. That puts a 1. X minus 3 squared over 64 plus y plus 2 squared over 4. There we go. There we go. So now we can do all the rest, right? We can just make that 8 squared, 2 squared, do the graph. What's the center?
3, negative 2.
Yeah, opposite, opposite. Center is 3, negative 2, over 3, down 2. There's the center. So is this graph wider or taller? This egg-shaped ellipse, wider or taller? It's wider because the x is bigger, huh? So I'm going to add 8 and subtract 8 from the x-coordinate, aren't I? To find the vertices and And so that would be, so way over here and way over here. Add 8, that would be 11, negative 2. Subtract 8, that would be minus 5, negative 2. You okay with those two? See, I'm just adding 8. 8, 3 plus 8 is 11. Subtracting 8, 3 minus 8 is negative 5. Is that good? And I don't really care how high it goes. They don't really add. They just ask me for the vertices, which is the, remember the vertices are the longest edges. They're not going to ask you for these top and bottom points, I don't think. Right, Taryn, you remember when you looked at it? I think they just want the vertices, which is the longest edges. So just those two. Last thing then, focus points. Can we find the focus points? The focus, yeah, so it's a squared minus b squared is c squared. So remember, a is the bigger one, right? Because you're subtracting bigger one first. So 8 squared minus 2 squared. So 8 squared minus 2 squared is c squared. 64 minus 4, that's 60. Is c squared. Root it, root it. Okay, there you go. There's another chance for a root. Can you root that 60? Remember how to break those down? So that's 4 times 15, which is 215. Right? So now what do we do? 2 2's in?
1 out.
1 2 out. 2 root 15. The 15 has to, you can break down 15 if you want, but that's 3 times 5, no pairs there, so the 15 goes back together inside. Is that good? Everybody see that? Right? Because when you break down the 15, 3 times 5, there's not 2 3s. There's not 2 5s. If there's not 2 of you, you stay it in. Right? The only way you go out is if there's 2 of you.
So there's 2 ones that can't be a 2 for 1, you just combine them in. That's
Yeah.
better.
You just remultiply them. Just like they were multiplied before, they just remultiply and stay in. That's right. So 2 root 15? 2 root 15. Now where is that? That's this one's wider again, so that's right and left. The focus points are right and left. So you add and subtract the 2 root 15. So the focus points, the foci, are 3, whoops, take the x-coordinate of 3 plus 2 root 15 and 3 minus 2 root 15, comma negative 2. Is that good on that?
What?
So there we go. Questions on that? Better move on, huh? Let you do the rest. So, all right. So, yeah, try that one. You gotta get the X stuff gathered up, the Y stuff gathered up, push the 1021 to the other side.
They want to know the HK, the vertex,
Mm-hmm.
the right and left of the centers, the foci, and the picture.
Do you want to know, say it again?
They want to know a bunch of stuff. It's like that.
Vertex right of center, vertex left of center. Focus, yeah. Right, that's exactly what we did last time. Yeah. No, so they're still not asking for the smaller direction. They're just asking for the big one. So 25x squared plus 250x. So I gather the x stuff together. They kind of all shuffled around. Gather the y stuff together. Push the 1021 to the other side. Comes a negative 1021. Everybody good so far? Got the x stuff gathered, got the y stuff gathered, push the 1021 to the other side. Okay, now you know what to do, right? Factor out. Take out that 25. Leave a blank. Take out that 36. Use your calculator. How do you find the number inside? Divide on your calculator. Do you know what I mean? When you factor out a 36, it's kind of like with the parabola. Remember what we did? We factored out a 4, so which means we had to divide by 4 to find the new a. Same thing here. If you factor out a 36, you got to divide by 36 to find out what will times to go back. So please tell me, what is 432 divided by 36?
12.
12? Thank you. 12y. Good to there? So now find the magic number, the completing number. Find the completing number for x. Completing number for y. Remember, whatever you really do to the left side, you got to really do to the right side. The real effect. So you take whatever's in the middle, put it over 2, mid over 2 squared, 5 squared, 25. So I put in, it's always positive. The completing number is always positive. So plus 25 under the influence of another 25.
So that makes it cancel.
6, 20, or you want me to write 25 times 25? That means I really added 25 times 25 to the left side. I've got to really add 25 times 25, 625 to the right side.
Can I just put 25 squared? No?
Sure. That makes sense? Everybody see why that's the case? When I added this 25 to the left side, if I was to multiply out the left side, really there's a new 25 times 25. That's what I really did to the left side when I added a 25 under the influence of another 25. So I got to really do that to the right side. And then for the y, grab the mid, over 2 squared, negative 6 squared, positive, it's always positive, positive 36 under the influence of another 36. So I really have to add whatever 36 times 36 is.
12 times
So now, what do we got? 25. These three will factor. X plus 5 squared. Y minus 6 squared. What's that right side? All together?
900.
900? Nice clean 900? It's nice when you get numbers like that, huh? You know something good's happening. It is? It's exactly 900? All that?
Yeah.
Great. Everybody see how I got there? See how these three factored? Right, that's what the completing number did, is made it factor as a square perfectly. Completed the square. All right? Is it all coming back from algebra now? A little bit? All right. Now, what do we got to do? Final step to give it the right look? Divide by the 900. We've got to get a 1 over there. When you see that 900, don't you feel like this baby's working out? That's a good number. If you got like 812 or something, you'd be like, oh, I made a mistake somewhere. So 36 into 900, isn't it just like 25 times?
Yeah.
Beautiful. 25 into 900, 36 times. X plus 5 squared over 36. Y minus 6 squared over 25 equals 1. The rest you can do, right? Find the center, find the focus points, blah, 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 blah. Good on that? You feeling comfortable with completing the square? Is that all good? All right. Let me just do this one quick.
Didn't you say 3 minutes every question?
I know. I'm a little off the pace. I'm terrible at it. Do you notice that x squared, there's no, here's what I want to help you. This gets people, I remember in the past. No x to the first power term, so x is done. Right? 48x squared is done. There's nothing more to do with it because there's not a regular x anywhere. It's just 48x squared, period. Whereas we have y squared and y, so we need to complete the square on y. Only y. So okay. So what's the magic completing number? Take the mid over 2 squared, which is 12 squared, which is 144. So add 1. Oh, by the way, there was nothing to factor out either. There was nothing in front of y squared to factor out, was there? So this is an easier one. Add 144 to both sides. Now what do we have? 48x squared. The y's are guaranteed to factor. What is it? Y minus 12 squared. 144. So everybody see that? Do you see how I didn't have to mess with x? There's no x to the first power term, so x is done. You only have to complete the square when it's got x squared and regular x. You got to gather those together. But if you just have x squared, you just have x squared. He's done. He is a square. Yeah, maybe that's a better reason. He is a square. He's x squared. X minus 0, if you want, squared. Right? He is a square. It's only when you have squared and like y squared and y. Oh, no, we got to get them to complete, right? Everybody see that? So no need for x on this one. He is a square already when it's just him. Squared. All right, so last step, divide by the 144. Divide by the 144. 48 goes in that. 3, thank you. So it's x squared over 3 plus y minus 12 squared over 144 is 1. So, yeah, so what would be the center of this one?
Down. Oh, up.
0 plus 12, right? Because there's nothing next to x, which means 0. Nothing added or subtracted next to x, which means 0, 12, okay? And now, yeah, and then, yeah, the rest is, this is 12 squared. This is square root of 3 squared, right? Plane 3, I don't know, we haven't had one yet that isn't squareable. Is that a word? You know what I mean. So that's root 3 squared, is what you do. Root 3 is a decimal number, 1.7, whatever. So, there you go. I better move on. Everybody got that copied down? Like that. All the rest is normal from there. All right, let's do what we can. All right, so find an equation. This is a little tricky. I mean, I know the multiple choice helps. That's how the real test is. So find the equation of the ellipse graph. This is actually pretty tough for people, at least it has been in the past. Give me vertices and a focus. Definitely need a picture. Even though they're not requiring it, well, I guess they are. Graph, yes, I guess I do. Even if they didn't, picture is really helpful. So let's do that. So I'm going to do that. So let's put the vertices on there, minus 2, minus 4. Right there. And the other one is minus 2, 8. Good, so there's the two vertices. Focus, minus 2, 4. There's the focus point. Minus 2, 4. That's all they give me. Find the equation. You know what's most important?
Yeah.
Center. Yes. Good guessing skills. No. Center. Got to find the center. How do we find the center? How do you know that? Oh, negative 2. Yeah, because negative 2 something. I see. Yeah. It's going to be whatever the middle of this and this are, right? The middle of the two endpoints, huh? How do you find the middle of two things?
Just add them up and divide by 2.
Good. Average them. Add them and divide by 2. That's the middle. So I got to take the 8 and the negative 4, add 8 and negative 4, divide by 2. That's 4 over 2, positive 2. So that means at up 2, right here, at up 2. And of course, like Taryn said, it's back 2. Of course, it's back 2, up 2. There's the center,
Easy
huh?
peasy.
Is that good? Everybody good with that? Finding the center is everything. The center of those two vertices. Okay, that's the center. Opposite, opposite. So we know the equation is going to have x plus 2 squared over something plus y minus 2 squared, right? Opposite, opposite over something equals 1. We know that much already, right? You guys with me? Right? Whenever we have the center for any of these pictures, it's always opposite, opposite to the equation, isn't it? So we know it's like that. So forget this answer. Forget that answer. It's A or C. Because they have the x plus 2 and the y minus 2. Good? So now, got to figure out which is which. So what do we do from here? How far from here up is it? Goes from 2 to 8. From 2 to 8. It's plus 6.
So 6 to the square.
6 goes underneath what? It's up.
Y.
Y. 6 squared. 36 is under y. There it is. Right? Not good? Everybody see that? We didn't even have to find the other one.
We could have just guessed and just put A.
Hey, you get 3 tries after you know that.
3 tries, right? Good? All right, I'm going to move on to students. So let's look at them. So, okay. So focus points, 6, negative 4, 1, 2, 3, 4, 5, 6. 6, negative 4, and negative 2, negative 4. So these are the two focus points, which are always inside the egg shape, aren't they? So the real egg shape is bigger. Is this ellipse wider or taller?
Wider.
The focus points are always on the major axis, so this one must be something like that. It's just helpful for me just to get a general look at the thing. It's wider than it is tall, right? Because the focus points are sideways. They tell you the major axis. Okay. And then it says length of major axis, 16.
So it's 8 up and then 8 down?
Major axis is sideways, so it's 8 over each way. From the center. But where's the center? Got to find the center, don't I?
Divided by 2.
Yeah, so let's find the center. Can you do that? So let me let you find the center, and then you know it's, 8 right and left from the center because the major axis is 16. See how we use that? So find the center. This one is at back 2. This one is at over 6. So the center is atom and divide by 2. It's 4 over 2, 2. So it's right here at 2. 2 minus 4. There's the center. Everybody good with that? That's the center. And now, length of major axis 16. That means you add 8 to the x coordinate. That'll be 10 minus 4. 7, 8, 9, 10. So right here at 10 minus 4. And then, see what I did? I just added 8 to the x coordinate because it's 16 is the major axis, which means 8 each way. And the major axis is sideways because the focus points are sideways, right? And then subtract 8. So minus 6 minus 4. 3, 4, 5, 6. One right here. So here's the edge. Here's the edge. That's really where the edges are. So my graph is off a little bit, of course. Like that. All right. So now, can we get the equation? So now, let me let you do that. Can you write that equation? Maybe I better do it quick. So opposite, opposite. Take the center. 2, negative 4. Opposite, x minus 2 squared. Y plus 4 squared equals 1. Good so far? I just took the center and I did opposite, opposite to the equation. Now what goes under x and y? What goes underneath x first off? Right and left. How far right and left? It's 8 to the right and left, so 8 squared. Good. What's underneath y?
I don't know.
We don't know. We got to use the focus equation. Because we know how far to the focus. How far to the focus?
Oh, 4.
4.
So 4. And then that would be...
That's the
16.
c squared.
Oh.
Right? Remember the focus equation? A squared minus b squared is c squared. That's the c is the focus. Remember that? And the c is 4. You with me? See, these are how far. The c is how far from the center to the focus. So from the center to the focus, from 2 to 6, is 4. So the c is 4 in the focus equation. You with me? Now, with the a and the b, remember the bigger one has to come first when you subtract two things. Which one's bigger? The x number or the y number? How do you know it's x?
Because it's the foci.
Because it's wider, because its foci are sideways. Exactly. It's wider, so this is the A, and this is the B. The A is the bigger. They can switch them, though, right? If this ellipse was taller than it is wide, then the A would be under the Y. Remember that A and B are interchangeable. A is whoever the bigger is, bigger direction. If it's taller, the A is what's underneath Y. If it's wider, the A is what's underneath X. So A squared minus B squared, so 8 squared minus B squared is 4 squared. So that's 64 minus b squared is 16. So b squared, I'm kind of running out of time here. Minus b squared, subtract 64. So minus 48. And then so b squared is 48. So I'm just going to put 48. I mean, that's what b squared is, 48. So I'll just do that. So we're done.
It's 48 squared?
It's not 48 squared.
It's 48.
B squared is 48.
Oh, okay.
Right? That confusing the way I did that? That okay? There it is. Good? That okay? All right. Heard? Basically, if you stand at one point in the gallery that's at the end, and somebody else, it's basically the two focus points of an ellipse is what it is. And the ceiling is elliptical shape. And so if you stand at one focus point, you could just barely whisper and the sound will bounce exactly to the person standing at the other focus point and they can hear you, even just a whisper. They made one of these in, I think it's someplace east. So anyway, so let's figure it out with our 3 minutes that remain. A hall 110 feet in length is to be designed as a whispering gallery. Focus points are located 15 feet from the center. How high will the ceiling be at the center? So basically I've got an ellipse. The focus points are 15 over each way. Back 15, over 15. That's where the focus points are. The hall is 110 feet in length. So this is, it's 110 total. So half of that, this is what, 55? 0? And minus 55, 0. 55 is half 110. You with me? So then, and they're asking me how tall is it in the center. So that's the b. A squared plus x squared over a squared plus y squared over b squared is 1. They're asking me for the b, aren't they? Right? Because the a is the bigger. It's wider than it is tall, you can see. I think, isn't it? Yeah, it's got to be because the focus points are sideways. So the A is the 55 squared. The B, I don't know. How do I find the B? Focus equation. A squared minus B squared is C squared. I know the focus is 15, huh? 15 squared. A is 55. 55 squared. Solve for B. B will be the height in the center. Because B is what's underneath Y. It's the height, huh? So just solve that equation for B, you got the answer. Is that good? Let me go back and set up that other one, the point one. That was easier than I thought. So these bridge ones are like, the bridge one is like this too. We did a bridge one for parabola. Look back, I mean, you got to use the ellipse equations, but it's similar. Let's go. So they're saying, all right, equation ellipse, blah, blah, blah. Center is 2, 4. Over 2, up 4. And focus is 2, 7. 2, 7 is the focus. This is the center. And contains the point 3, 4. Kind of running out of room here. Contains the point 3, 4. All right. So there we go. Good so far. Does this ellipse go up, down, or side? Is it taller or wider? Focus point is up. It's taller. And it hits this point, but the focus is inside of it. It doesn't hit the focus. Those are inside of it, right? It goes beyond them. Something like that? Good so far? Find the equation, okay? Here's the center, opposite, opposite. X minus 2 squared over something. Y minus 4 squared over something is 1. Opposite, opposite. Now, what's underneath X and what's underneath Y? Well, if it has the point 3, 4, I know how far right it goes. How far right does it go?
1.
Just 1. This is only plus 1. And where's that go? If it's right 1, does that go underneath X or Y?
X.
X is right, left. That's 1. Now this is what is underneath Y? Is it A or B? Remember, A is the bigger.
Oh, A.
It's A because this thing is taller than it is wide. So what's underneath Y is the A. It's bigger. So now, how far to the focus? 3, up 3. So focus equation. We always come to this focus equation, don't we? So the C must be 3. Everybody see that? 3 squared, A squared minus 1 squared. Solve for A. You got it. Is that good? Everybody see that? All right, that's all we got time for.